Alright, what's going on, guys? ErickMed here. Now, before I go ahead and break this passage down, okay, it's very important that you guys do the passage on your own first and answer these questions on your own first, and then you guys hear me break it down. Okay, it's very important for you guys to do that first. Okay, if you do that, that's how you're gonna get the most out of this video, and that's how you're gonna get those big score jump increases in your practice test, going up 5 to 6 points in your CP and BB sections, okay? That's how you improve, by realizing where you fucked up and fixing it, okay? So I'm going to go through the questions in a second so you guys can see the questions. But in order for you guys to take this very seriously, because I want you guys to take this passage very seriously, we're going to do a little imagination experiment here, okay? So I want you guys to close your eyes, okay? Close your eyes. Are they closed? Okay, good. Now I want you to imagine that today is test day. Okay, today is the day that you are taking the MCAT. You wake up in the morning, you roll out of bed, okay, you check your phone, and the date on your home screen is the day you are taking the MCAT. You get up from bed, you go and do your morning routine, whatever it is, okay, you have your favorite breakfast, you go through the day. And when it's time to leave your house, you get in your car, okay, you play your favorite song, and you drive to the test center. You arrive at the test center, you open the door, you make your way down the hall, and you find the examination room. Now, before you open the door of the examination room, I want you to imagine and realize that you are feeling completely confident, completely prepared, calm, and ready to do extremely well on the MCAT. You trust all the prep that you have been doing and all the years in college you have been learning. You trust every single time that you studied and put in the work and all those, tears and whatever you guys do, okay, all that stress, you're trusting that it's all going to pay off today because you know for a fact that you are going to hit your target score on this test. You are feeling confident and you are ready. You open the exam room door. The test proctor leads you to your desk, okay? And right in front of you is a computer. You move the mouse, okay? The computer lights on, and you see that you are about to take the MCAT. The MCAT asks you, hey, do you want to do a tutorial? You say, no, you're a G. You don't need to do no fucking tutorial. You already got this shit, okay? You skip through the tutorial, and you go and you click begin test. You begin the test, open your eyes, and this is the first passage that you see. Okay, this passage right here in front of you is the first passage you see. Okay, your eyes should be open at this time. Okay, so this is the first question, guys. This is the second, third, fourth, fifth. Okay, I'm going to scroll down here. Okay, next question. And okay, that's it. So pause it whenever you need to. Okay, pause it whenever you need to. Write down your answers and resume this video because I'm going to be breaking this down. All right, cool. Let's do this. The human intestinal tract is inhabited by a diverse assortment of microorganisms known as gut microbiota. Okay, you should know what that is. These microbial populations are increasingly implicated in the regulation of host metabolism and the development of obesity and diabetes. The catabolism of dietary fiber by gut microbiota results in the production of short-chain fatty acids such as butyrate and acetate, which are important energy sources for the host. Short-chain fatty acids also act as signaling molecules with the ability to bind and activate G protein-coupled receptors. Okay, quick little thing here about these two paragraphs. Gut microbiota, we should know what that is. Bacteria in our gut that help in digestion, and in this case, they make butyrate and acetate. Okay, and this butyrate and acetate is an important energy source, and they activate GPCRs. You should know what GPCRs are. Okay, nothing too crazy. All right, I'm just going to highlight this. To remind myself, butyrate and acetate okay, come from the catabolism of dietary fiber. It's the bacteria in our gut that make butyrate acetate. Now, what does this butyrate acetate do? I'm pretty sure that this whole entire passage is going to tell me what it does. Okay, but let's keep reading. The GPCR 43, is expressed in white adipose tissue and is not expressed in muscle or liver. Okay, this popped out right at me. This is a straight fact sentence that they just threw right in your face, so I'm going to highlight it. Whenever you get an idea that they just throw some random sentence at you with a straight fact, okay, whenever they use not or always, those extreme words, okay, you highlight it. You highlight it, okay? Researchers generated GPCR43 deficient mice to analyze the contribution of GPCR43 to energy regulation. Cool, okay? They just told me right here what the heck this whole thing is going to be about, okay? They want to know what the fuck GPCR43 does. And how do you know what the fuck a gene does? Okay, what scientists do is they knock it out. They get rid of it. To find out what a gene does, you get rid of it and you see what happens. Okay, if something different happens, then that means that that gene is involved in something. Okay, that's a very common knockout technique in research. You should know for a fact what that is. Okay, it's very common in the MCAT. So they want to know what the fuck does GPCR43 do. So they knock it out. And this is probably, okay, see here, body weight, this is what the heck GPCR43 does. Okay, wild type and GPCR43 knockout mice were fed a standard diet or a high-fat diet, and their body weight in grams was measured weekly for 16 weeks, figure 1. Okay, cool. They want to see what the fuck GPCR43 does. Does it get you fat? So they knock it out and they compare it to the wild type. Very classic research experiment done here, okay? Do not look at the figure, yeah. Do not look at the figure. Only when the question asks for it, you look at the figure, okay? I said that in my bunch of videos, but it's very important that you don't waste time on this figure, okay? Next. Researchers examined the relationship between GPCR43 function and insulin sensitivity. Adipocytes, which are storage fat cells, from wild type and GPCR43 knockout were incubated in the presence and absence of both insulin and acetate, and the uptake of radioactive glucose was measured. Okay, so here they decided, okay, what does GPCR43 do? Does it get you fat? And here they decided, okay, now, what does acetate and insulin do? What does acetate and insulin and acetate do when we knock out GPCR43? Okay, that's what they measured here. I don't have to look at this figure, but I already know that they're measuring, okay? If we knock out GPCR43, what the heck does insulin do? And if we knock out GPCR43, what the heck does insulin and acetate do to the cell, to the uptake of radioactive glucose? Okay, so we have a very good idea of what this passage is about, and I actually really enjoy this passage because it shows a lot of very common MCAT research techniques and all this stuff. Okay, so this is a good passage. This is fun. Which table shows the expected body weight of wild type and GPCR43 knockout mice fed a high-fat diet while housed for 16 weeks in a conventional condition or a germ-free condition where the gut does not become colonized? Okay, a germ-free condition. That means we do not have bacteria in our gut. If we don't have bacteria in our gut, we're not going to make butyrate and acetate. Butyrate and acetate activate GPCRs. They activate GPCR43. If we are not activating GPCR43, then it's essentially the same result as knocking out GPCR43. Okay? Now, what the heck does knocking out GPCR43 do to the cell, to the animal, to the uptake of glucose, to our body weight? That's what the figure is for. Okay, let's check the figure. Now, once you reach a figure, okay, this question you have to look at the figure for a fact. Okay, it's very obvious you have to look at the figure here. So when you have to know to go to a figure, or if the question they say, oh, based on this figure, blah, blah, blah. Okay, you go to the figure and you slow down, okay? Slow down when you assess these figures, okay? Slow the fuck down, all right? 9 times out of 10, they're going to ask you a question about the figure. So slow the fuck down, okay? This is a pretty easy figure, so we don't have to spend that much time on it. But a lot of time, the other figures will show up a bunch of like Western blots, or some SDS pages before and after the experiment, or they'll show like the negative control and the positive control and all this stuff. Okay, slow the fuck down when you reach these figures, because you have to make a conclusion off these figures. The MCAT wants you to make conclusions, so you make a conclusion off the figure. This is where your fucking ride or die here. This is where, if you're gonna get the whole passage right, comes along. Okay, when you make these conclusions, okay, if you make the right conclusion, you're gonna get majority of the questions right. So let's make the correct conclusion here. Okay, I already talked so much here, but let's keep this going. Okay, so time to make a conclusion. Always look at the wild type first. No matter, I don't give a fuck who says what. You look at the wild type first. Okay, wild type. Here's the circles. Cool. Over time, we gain a little bit of weight. That makes complete sense, okay? Now we look at the knockout for a standard diet. So this was standard diet. Now we look at the knockout, GPCR 43 knockout. This is black squares here. When we knock out GPCR 43 in a standard diet, look, we gain a little bit of weight. We gain weight, okay? When we knock out GPCR 43, we gain weight in a standard diet. Now let's look at this one. What are these triangles here? This is the wild type with a high-fat diet. As you can see, we gain more weight. Okay, makes sense. It's a high-fat diet. Of course we're going to get fat. It's a high-fat diet. Now let's see what happens if we knock out GPCR 43 in a high-fat diet. Boom! We gain a lot of weight here. Okay? Look at all that weight we gain. Whenever we knock out GPCR 43, we gain weight. Okay? So what's the conclusion we make? We make the conclusion that when we knock out GPCR 43, we gain weight. Okay, so what does that mean? That means we need GPCR 43 to stay lean. Okay, that's the conclusion you have to make. That conclusion I just made is probably going to get me the majority of the questions right. Okay, it's a very important conclusion. The MCAT wants you to make conclusions, and you have to be confident to make conclusions. That's why I stress confidence so much. Okay. So, which table shows the expected body weight of wild type and GPCR 43 knockout mice fed a high-fat diet while housed for 16 weeks in a conventional or germ-free condition? Okay, so germ-free, bacteria, no butyrate acetate, no activation of GPCR 43. It's basically like it's knocked out. Okay, so wild type conventional, 58 grams. Okay, GPCR 43 knockout conventional, 52 grams. What happened here? We lost weight. That is not what our conclusion was, okay? Our conclusion was when we knock out GPCR 43, we gain weight. This is saying we lose weight, so this is wrong, okay? Let's check B. Wild type conventional, 40. GPCR 43 knockout conventional, 57. We gain weight, okay? So you're okay for now. We'll leave you for now. Wild type conventional, 40. GPCR 43 knockout conventional, 61. We gain weight. Okay, cool. We'll leave you for now. Wild type conventional, 65. GPCR 43 knockout conventional, 52. We lose weight here. That is not with our conclusion. That is not with the figure. So you get the fuck out. Now we're left with B and C. So now we got to choose between these two. Okay. So germ-free. Germ-free means, like I said before, no bacteria, no butyrate acetate, no activation of GPCR 43. It's like our GPCR 43 is knocked out. Essentially, we should get the same result. Okay, so conventional 40, germ-free, we gain weight. Correct. Okay, that's with our conclusion. Conventional 40, germ-free, we lose weight. No. Okay, if we're germ-free, we're going to gain weight. So you get the fuck out. This makes sense. I'm completely confident that B is the correct answer. Let's see. Boom, it is correct. Here's the explanation. Okay, remember guys, when I do this, okay, look at the time. Okay, it's never changing. I don't edit these videos at all. This is just one take for me. And I haven't seen this passage in like fucking year and a half. And I think I didn't even do this one because this does not have no memory for me at all. Okay, which amino acid is least likely found in one of the transmembrane domains of GPCR 43? Transmembrane, you should know and think nonpolar, hydrophobic, okay? So least likely to be found there is something that is not hydrophobic and is not nonpolar. So aspartate is not hydrophobic. Glycine is hydrophobic. Tryptophan is hydrophobic. Phenylalanine is hydrophobic. Answer is A. Compared to wild-type mice, which experimental group of mice is most likely to remain lean when fed a high-fat diet? Okay. So what did we say 1,000 times? We said if we knock out GPCR 43, we gain weight. Okay. GPCR 43 is essential to stay lean. Okay. If we treat the mice with antibiotics, what's going to happen? We're going to have no gut bacteria. We're going to have no butyrate acetate. We're going to have no activation of GPCRs. And if we have no activation of GPCRs, it's essentially like it's knocked out. And if it's essentially like it's knocked out, then we're going to gain weight. So this is wrong. Okay. Mice treated with the GPCR 43 antagonist? No. Okay. We like GPCR 43. It makes us stay lean. When we don't have it, we're going to get fat. Our goal is here to remain lean. We want to remain lean. If we have an antagonist for GPCR 43, we're going to get fat. It's like we're knocking it out. Mice in which GPCR 43 is overexpressed in white adipose tissue? Yes. Okay. We need GPCR 43 to stay lean. Okay. And if we overexpress it, we're probably going to stay lean. Mice treated with a drug that inhibits the generation of intracellular second messengers. Okay, this is wrong because it fucks up the whole signal transduction pathway, okay? The way GPCR works is that something binds to the receptor, and then it activates, dissociates the alpha unit, I'm pretty sure it's the alpha unit, dissociates, activates, blah, 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 and we get a second messenger, okay? If the second messenger is inhibited, then it's basically like our whole entire GPCR 43 was useless and there was no point in it, okay? So this is wrong. And this is right. Boom. Look at that. Okay. Look at that. Now, I really, really enjoy this passage, guys. Okay. This is very, very representative of the MCAT because it's like you hear me say, like, I'm kind of like a record on repeat here. Okay. I say, if this gets knocked out, then this happens. Okay. And if this happens, then we don't have this. And if we don't have this, then it's going to act like this. Okay. If this is knocked out, what happens? If we do this, what happens? That's what the whole entire MCAT is, basically. Okay, that's what a lot of these passages are. Which conclusion about glucose uptake is best supported by data in Figure 2? Okay, like I said, go straight to Figure 2. I don't give a shit about anything else. Go to Figure 2, okay? I say that, and it's pretty obvious, but a lot of you guys, for some reason, like to use information that is non-Figure 2 to answer Figure 2. Like, no. Just go to Figure 2, man. Stop overcomplicating it. All right, let's look. Okay, I see an arterisk here. I think that's how you pronounce it, arterisk. But when there's an arterisk, okay, that means we have something significant going on here. Okay, if you took statistics, you would know what the heck that is. You don't have to take statistics, but a good idea of statistics helps. So what this means, okay, quickly, you see how this goes up a little bit? We don't give a fuck, okay? That's not significant. There's no arterisk here. We don't give a fuck about that. It's essentially the same, okay? This is the same. This is a big difference. That's why there's an arterisk. And this goes up a little bit. Okay, even though this goes up a little bit and this goes up a little bit, it's not significant. Okay, it's not significant. The only thing that's significant is arterisk. So let's see what happens. Okay, what happens here in this arterisk? Here's the wild type. When we have insulin, we have a big radioactive glucose uptake. Okay, this makes sense. Insulin does help with glucose uptake. That's the point of insulin. Okay, when we don't have insulin, what happens? We have little glucose uptake. When we add insulin to wild type, we have big glucose uptake. Okay, makes 100% sense. That's what fucking insulin does. Now, when we add acetate to the insulin, we go down in glucose uptake. We are suppressing glucose uptake when we add acetate in the wild type. Okay, makes sense here. Now, after we look at the wild type, we look at the knockout. Okay, so here's the GPCR 43 knockout. When we have insulin, goes up. Makes sense. When we have acetate, goes up. So it's actually a little higher, but it's basically the same thing here. So what conclusion can we make? Okay, when we add acetate, boom. Okay, no suppression in the knockout. When we add acetate in the wild type, boom, look at that suppression. So my conclusion is that in the wild type, when we add acetate, it suppresses glucose uptake. Okay, but in the knockout, when we add acetate, it does not suppress glucose uptake. Okay? Acetate suppresses insulin-mediated glucose uptake in wild-type adipocytes, but not GPCR43 knockout adipocytes. This is exactly what the heck is happening here. In the real MCAT, okay, I would not even take a look at these. I would literally just not waste my time and be very confident this is the correct answer. Okay, but I'm gonna look a little bit here. Okay, for the video-wise, you could skip this part if you want. Acetate stimulates an insulin-mediated glucose uptake independently of GPCR43. No, it does not do that. It suppresses it. Insulin suppresses glucose uptake. Why would insulin suppress glucose uptake? That does not happen here. Insulin stimulates glucose uptake in wild-type adipocytes, but not GPCR43 knockout adipocytes. Okay, it does do that in wild-type, but let's see in GPCR43 knockout. Okay, here's insulin. We're over here with the knockout. And when we have insulin, it's up here. So comparing this one to this one. When we add insulin, glucose uptake goes up. It stimulates it. This question answer choice is saying that it does not, when it obviously does. Insulin always stimulates that shit. So this is wrong. The answer is A. Boom. Next question. Insulin signaling results in the phosphorylation of the downstream target AKT, which can be quantified by Western blot analysis. Which graphic shows the effect acetate administration will likely have on AKT phosphorylation levels in white adipose tissue and muscles of wild-type mice? Okay. Acetate, like we said earlier, it suppresses insulin, the activity of insulin. Okay. If it suppresses the activity of insulin and AKT is something that's part of the pathway of insulin, then when we add acetate, AKT's phosphorylation is going to go down. It's going to go down. Okay, that's what acetate does. Acetate, suppresses insulin, as you can see here. So AKT, which is a buddy of insulin, is going to get suppressed just with insulin when we add acetate. Okay, so here's white adipose tissue. Okay, here's insulin. When we add acetate, stays the same here. This is wrong. Okay, when we add acetate, it should go down. This is wrong. Here, when we add acetate, it goes down. Okay, that's correct. You could stay for now. When we add acetate, it's the same here. So this is wrong. We need to see some suppression when we add acetate. Here's insulin. Here's just insulin. And here's when we add acetate. We see some suppression. Okay, good. You can stay. You two, that's a debate between you two. B and D. Okay, what's the difference here? Well, B, in the muscle, they stay the same, the phosphorylation, when we add acetate. And in D, when we add acetate, it goes down. Okay, I know that acetate suppresses insulin activity in white adipose tissue, but in muscles, does it? Does it do that in muscles? Aha! I fucking told you guys, bro. Whenever something sticks out of you, you highlight that shit. Okay, wow. Okay, this question tried to fucking trick you guys. Okay, motherfuckers out here, okay? Look at this. They just low-key added in this passage that GPCR43 is expressed in white adipose tissue and is not expressed in muscle or liver, okay? If GPCR43 is not expressed in muscle or liver, then it's not going to make a difference if we add acetate, okay? It's not going to make a fucking difference because it's not even expressed there, okay? It's not even there. So they try to trick you here. So this would stay the same, okay? The answer is B. Look at this. They try to low-key trick you. They try to low-key put this thing here and just think that you're not going to see it. You're just going to overread it, blah, blah, blah. Like, no, fucking MCAT. Really? Like, really? They try to trick you out here. Look at these tricks, guys. Recognize these tricks. Fuck out of here, MCAT. I got that right. Okay. Compared to untreated wild-type mice, antibiotic treatment of wild-type mice is likely to result in, okay. I sound like a broken record here. Antibiotic treatment, okay, that kills bacteria. If we kill bacteria, we're probably going to kill our gut microbiota. If we kill our gut microbiota, we're not going to have butyrate and acetate, okay? So we're not going to have increased plasma butyrate levels. That's going to go down, okay? We don't have the bacteria to make those butyrate levels. Decreased body mass. If we don't have butyrate and acetate, we're not going to activate GPCR43. If we don't activate GPCR43, it's essentially the same thing as knocking it out. So we're going to get the same result as knocking it out, which is we're going to gain weight. Okay, if we knock out GPCR 43, we're going to gain weight. So this is wrong. This is saying we're going to lose weight. We're going to gain weight. Increased volume of adipocytes, yes, because if we gain weight, okay, then we're going to have more fat cells. Adipocytes store fat. This makes sense. Decreased insulin sensitivity in adipocytes. Let's see here. Okay. Oh yeah, look. All right. The bacteria make butyrate acetate. Okay, acetate, as we said before, suppresses insulin sensitivity here. Okay, if we don't have insulin, if we don't have the acetate, we're not going to get this decrease. We're not going to get this decrease if we don't have acetate. Okay, so if we don't have acetate, we're not going to get the decrease. So it's going to stay the same. We're not going to have this. Okay, answer C. And that's it. That's literally it, guys. That's a very great passage. Okay, absolute amazing passage. Okay, I hope you guys took this seriously because this is very representative of how the BB passages are in the MCAT. Okay, it's very, very similar to how it is right now. I know you guys are probably wondering, I got a bunch of emails. My tutoring is closed for another 2 weeks, okay? In 2 weeks, I do have a couple spots opening. So in 2 weeks, I will probably post a video and announce it. And from there, I can take on new pre-meds to tutor, okay? I do tutor in the BB and CP sections. So if you're interested in that, actually, if you're interested in that, send me an email right now and be like, yo, Eric, like, I want the spot in 2 weeks. Can I, like, be on the list and stuff like that? And I'll be like, yeah, like if I have a spot for you, I'll let you know and stuff like that. So they fill up really quick, like really, really, really quick, okay? And I spend a lot of time tutoring my pre-meds and stuff like that. Like anyone in the program can know like how invested I am that they really get a good score on this, okay? So if you're interested in that, send me an email right now and be like, yo, Eric, in 2 weeks, like I want a spot, and I'll tell you if you get one or not. So send it right now because that fills it up. All right, so next time, ErickMed here. This is a great video. Fucking love this video. And I'll see you guys in the next one.